Welcome to video 7 in the tutorial series on Scilab and XCOS. In the last video, we modeled the kinetic energy of a dynamic velocity system, and this video, we're going to get introduced to sine functions, basic trigonometric functions. At the very beginning, go to Sources, click on the gen sine function, and bring it over. The sinks, bring a C scope, and again a clock. Right? So we connect these. Now let's see what the gen sine function is. So we have a magnitude. Let's define our magnitude to be 10. Let's define the frequency, which is in radians per second, to be 1 upon 100 or 0.01. This will be important in just a second. Let's say we want to plot two cycles of a sine wave. So we know that in one cycle of the sine wave, we have 2 pi radians. Now, since the angular frequency is given in radians per second, the simulation time can be found out. Now, 2 pi is equal to omega into the simulation time. So, the simulation time can be found out by the formula 2 pi by omega for one cycle. Now, that is what we need to change. So, as I said that if we have a refresh period of 30 seconds, then every 30 seconds it will keep refreshing its memory and we only get the latest 30 seconds of memory. So we want that to be, let's say if we're modeling for only one cycle, so that is 2 pi by omega. 2 pi is 6.28 and omega is 0.01. So it will be 628. So let's type in 628 here, and also in simulation, go to setup, and the final integration time should also be 628. Okay, now let's see if this runs. Yes, so you see that we have plotted one cycle with a maximum amplitude of 10 and a phase of 0. So because we set the phase to 0, right? So now we'll just experiment with this. Now let's say if we were to model a cos function is also a sine function but just displays by 90 degrees. So if you want to set it displays by 90 degrees, just type in percent pi by 2, because percent pi is already inbuilt into the Scilab memory. So this is a 90 degrees wave that will be leading it. Now let's see how this models out. So you see we have a cos function just by shifting the plot by 90 degrees. Right. So the next thing I wanted to introduce you to is something which is very important for at least plotting functions. So we'll delete this. So we have one gen sine block here. Let's have another gen sine block. So this gen sine block has a magnitude of 10, frequency of 0.1 and a phase difference of 90. So this is a cos wave. This here will be a sine wave. Let's keep a same magnitude, the same frequency, and the phase to be 0. So you can just double click on any space to create a text box like I've done here, sine wave, and here we have a cosine wave. Right. Now if we want to simultaneously plot both of these, then what do we do? Under signal routing, select MUX and bring it over here. Right, so what the MUX port does is it allows us to take multiple inputs and plot them together on the C scope. So we'll select the cosine wave here, the sine wave here, and connect them. So even in the MUX, if you double click, you have the number of inputs you need. So since we're going to be plotting only a sine and a cosine function, 2 is good enough for us. Right, so let's see if this runs according to our wishes. And clear enough, it does. So you can see how we can plot multiple curves or multiple variables on the same C scope using the MUX. In the next video, we'll also go over an example where we see how a three-phase current system actually works, where 3 sine waves are displaced from each other both temporally and spatially. But I hope this video was helpful to you. Thank you so much.